Hello, everyone. Welcome to another episode of Thoughtworks Technology Podcast. I'm Jean-Mac, one of your regular hosts, and joining me here today are Mike, my other host. Hi, Mike.
Hello, Jean-Mac. Hi.
And we have two of our awesome colleagues who work extensively in the field of data and ML, Danilo and David. Welcome.
So I'm Danilo Sato. I've been with Thoughtworks for 12 and a half years, and I've done a lot of things here in the company, from software engineering, infrastructure, and DevOps. But in the last 5 or 6 years, I got involved with leading our global data community and growing our capabilities around data engineering and data science. So that's kind of my field of interest, and that's kind of bringing all my background into that space. And I'm in London. It's about 9:20 p.m. now.
Great. I'm David Coles, and I'm based in Melbourne, Australia, where I lead the Thoughtworks Australia data service line. It's about 6 o'clock in the morning here. Unfortunately, we are about 24 hours off being back in lockdown as a result of COVID-19 cases in Melbourne. So looking forward to another 6 weeks of working from home now. But I count myself pretty lucky in the scheme of things. My time at Thoughtworks, I've been here about 9 years, and my background prior to Thoughtworks was in engineering and scientific software for simulations. But over time at Thoughtworks, I've been involved in everything from organizational transformation to prototyping smart TV applications. And in time, I found myself leading the data service line with that combination of skills and experience. And so we do data engineering work and ML product development work here in the data service line.
Thank you for waking up so early so we could catch Danilo before he goes to bed.
And the nice thing, I know folks listening won't help them very much, but we can all see each other on video because we're all on video as we record this. And it looks like David's had a haircut fairly recently, so he's not gonna get the COVID lockdown the long hair too soon.
I've also been having my haircuts at home, Mike.
Oh, you have? So all right.
I'm glad it looks good on the Zoom call.
Oh, there you go.
So maybe to kick off things, we had a theme on our technology radar that we published just late May called Data Perspectives Maturing and Expanding. And often themes are representative of the conversations we have and the numerous blips that end up on the tech radar when we generate that particular publication. And this particular theme was really a catch-all theme for a lot of blips and discussions around ever growing and maturing data engineering tools and techniques and architecture, to machine learning, new ways of training models, full lifecycle management of machine learning. So it was quite a wide spectrum of blips that fell in under this theme. So we thought we'd bring you today to share your perspective on some of these blips and share some examples of where you see them in action. So it's going to be a conversation goes to a lot of different, diverse topics under this umbrella. And I think this is particularly important because as we're going through this very special time, through crisis where, COVID crisis, the data has become such an integral part of solutions where, every norm just doesn't make sense anymore when we can't trust our guts. So I think this topic is most also relevant to what's happening right now in the world and the crisis that we see with the COVID, that businesses are struggling to predict what will be next, and trusting gut is not really an applied method anymore, and we have to use data more and more, as well as looking at the injustice that has happened and how can we use data in a just fashion and how can we remove injustice, and bias from our data. So I think that context and the time is very relevant to have this conversation.
Yeah, I think we've been seeing a whole range of changes with our clients in response to different patterns of customer behavior and societal freedoms or restrictions, as it might be, and also the demand for services and goods as a result of people's changing circumstances. We've seen everything from the total collapse of demand for airline travel, for instance, and that promotes one kind of data-driven response, all the way through to sustained surges in demand for companies that already supply goods or services remotely. For instance, Zoom video conferencing.
Yeah, we've seen some of the government work we've done in the UK as well. Some of the departments that they get a spike in demand, and there was a big demand for knowing more about like what's happening and how they should respond and how they should allocate their staff to deal with the crisis. And it was something that our team that were working in the data space there helped them basically bring up that, give them more real-time information about what's happening so they can make more informed and more timely decisions.
Yeah, I agree. I think the real-timeness is an important one. What we've noticed as well with a lot of executives, the dashboards that were driving the business and business decisions that made sense to be monthly or quarterly or weekly now need to be daily and near real time. So that's certainly a change. And I think in the healthcare space, that's just an obvious space that data is being used in so many different ways, from conversations or the rapid response through telemedicine and virtual care that generates a ton of information that then you can post-process, to just using it for population analysis and see how the virus is spreading. I geek out on the nightly COVID data for the county that I live in. And there is a ton of information that is being generated to use to make decisions, right? Make everyday life decisions. Send it to your child to preschool or not, just as one.
I think it also put a spotlight on like how to think about data and the importance of data quality and the meaning with the data, right? Like people became more aware of like, what does this actually mean? Is this number really like, is it the total number of cases? Is it how often is it updated? Like it brought some more real world understanding, I think, for everyone, not just us in the tech space, but everyone to be more aware of the importance of having that data and really understanding what it means.
Yeah, and things like leading indicators and lagging indicators. What's the and how to manage in a situation where it might take 2 weeks before you see the impact of a change has been from the primary health perspective. But as you've commented, the fact that things have changed so quickly has been a big impact wherever you are on the spectrum. We've had some of our clients where they've had more call center traffic in the first month after lockdown started than they had in the entire of 2019. And so then, a data challenge actually becomes a people challenge as well. How do you redeploy your people internally to best meet that shifting pattern of demand? And a lot of that's high touch interaction, novel scenarios. It's not established transactions that are efficient to process. It's actually a whole series of customized services that you need people to deliver. And then the focus on data solutions becomes more about augmenting people and enabling them to do more high value tasks more efficiently and improve the productivity of high value tasks rather than totally automating low value tasks. So it's and then that interaction of people and data solutions means you need to be able to iterate very rapidly to get insight and work effectively.
That's a great segue, I think, to talk about CD4ML, talking about rapid changes and iterative changes, and be able to put out an end-to-end solution and make it change it when that solution depends on data, that depends on ML. It's an interesting topic. So we had CD4ML as a blip for quite a while, I think, on the radar for about a year, I think. And this time around, we put it in the trial ring, which for us is quite a strong embracement as basically the thing to do. So I was wondering if you can unpack that for the audience, what it is, why we use it, where we use it, and give us some examples.
Sure, I'll give it a try. We first of all, like, why do we care about that? There is a lot of clients we go or industry problems where we see people trying to build these data solutions or train machine learning models, and sometimes it works in the data scientist machine, or they have a lab environment where they manage to get hold of some kind of subset of the data, they train something, but then it's really hard to get that into operations and put it in production. And CD for ML is our approach to tackle that problem. Continuous delivery is something that we at Thoughtworks, we've been doing that for a long time, even before applying this to this specific type of systems. But the idea of building systems, software systems that can, one that we can reliably release with high quality and at pace consistently, but also like all the automation and the supporting processes and the tools to enable that process to run smoothly is something that we've been doing. And I think when we think about CD for ML, when we're building an ML system, it's not just about the code that you're trying to push, but now we've got to deal with these changes in the data and the data sets, and also how we manage all the models and the training process that we're doing. So it adds a lot of complexity to the life cycle of that process. But when we think about continuous delivery, a lot of the principles that we apply to software, they still apply for machine learning systems. We want to release things frequently. We want to work in small batches as we can. We're not going to call something done until it's released. We want to try to version control everything. We're going to build quality into the product that we're building. So all those principles are still applicable. What changes is because there's more moving pieces, and the nature of the thing that we're tracking is also slightly different. So we need to change a little bit the process and the approach that we take. But continuous delivery for machine learning is basically trying to bring those principles to these type of systems and bring that discipline into that as well when we're thinking about the data moving around, the data being available, and then the training process for these machine learning models. How does those models get promoted, the process you put around them to ensure the quality is there in the model, accuracy and things like that. And then also the actual process of releasing them and how do you promote them to production? Do you replace the existing one? Do you compare with the existing model? So that whole discipline around doing that in a reliable way with the quality and the automation is what it's all about.
Because it does seem like even something like version control and repeatability, that's been something we've been doing in software for a long time. And even with software builds, like you need to take some care to make sure that you're using the same libraries each time that you build the software. Otherwise, you end up with something that's not repeatable. So in this case, we're talking also about tracking the data sets that we're using for training models. That seems hard even though, right? Like, aren't we talking about gigantic data sets and do you just check it into GitHub or like what happens there?
Potentially. We're not checking to GitHub, but yeah, this is one good problem. We're not going to be able to use the same tools as we're using to track code, but there are lots of tools about like how do we version data sets or how do we track changes in the data in a way that it's actually implementable, that's not going to overwhelm the tool. So there's a new set of tools, lots of new tools coming up to try to solve those problems. Because it's not just the data set. I think the data is one aspect, but then also like what is the machine learning training process on top of that data? Because that training process, sometimes like data scientists, they might want to split that data. They might want to validate against different data sets. They might be actually creating more data because they engineer new features on top of that, right? They want to improve the accuracy of the model and they can generate new features. Now they might be adding more data, but like they might be writing some code as well. When you're using the model, you want to make sure you calculate the feature the same way that the data scientists envisioned when they were training it. So there's a lot of these kind of complications that get bundled up into it that makes it complicated.
And forgive me for a very naive question, but like if you train a model the same way twice, do you get like an identical, binary identical, model at the end of it that you could compare and say, yes, I built that correctly because it was the same as the last time?
Yeah, if you track all the inputs.
There's a lot of inputs there, right?
Yeah, so there's a lot of inputs.
And there's also like some of the things is non-deterministic in the model training process itself. So like you might have things that like, for instance, random number generator seeds. Like maybe you train with the same model, the same input, but because the random number generator was in a different state, it will give you a different model, even if it wasn't the same input. So it's not deterministic in that sense that if we can try to make it reproducible to that point where we can compare input, output, and have a stable thing that doesn't change, then we try to do that. But when we think about quality and testing for this kind of systems, there's other ways to assess quality of the model that's not just making sure it's given the same input, it will give you the same output.
I think that's an interesting one because like while we, adapt the principles of continuous delivery now to a completely new realm and those principles applicable, the techniques and approaches and tooling would change. What you just mentioned, right? The non-deterministic nature of the models would actually require a different kind of testing, right? So I assume like now you're using a different kind of statistical based testing rather than logical, given this input, I'm expecting this behavior and this output. So that might change as well. Would you talk to that a little bit?
Again, and that's actually another really big driver for CD for ML as well, in that how do we determine that a solution is good enough for a particular purpose? How do we actually answer that question? As Danilo talked about the different modes of deploying a champion challenger, for instance, if we have an incumbent model, how do we know that a new model that we've trained is better than that incumbent? As one way of looking at it. And another way of looking at it is, are we ready to put this model in front of customers? And what threshold do we have to meet before we're ready to put this model in front of customers? And often that's a business discussion primarily, rather than a machine learning discussion. That it's actually machine learning becomes the forcing function for the business to define what good looks like in a particular scenario, because the machine learning model isn't going to be able to improve unless it has a clear signal for what good looks like and what better means in a particular scenario. And so CD for ML, like CD for software, pushes that quality and that definition of done conversation to the left. And so CD for ML, we might start by establishing a pipeline for the simplest model, which, fraud is a typical example. The simplest model might predict that every transaction is not fraud, but can we actually put all of the framework in place to be able to deploy that model into some environment where we can assess whether its performance is good enough or better than another model? And then can we iterate on the inputs, on the hyperparameters, on the features on the feature engineering for training or for inference, all of those sources of change? Can we iterate on those until we get to a model that is better than the incumbent and good enough to put in front of customers?
It seems like it is such an interesting space to be in, because you're working at the intersection of a lot of disciplines that we had before. Like what you just described, David, it reminded me of TDD, test-driven development, that you just, write your test and the simplest test and then write a dummy implementation even, for the body of that function. And then over time you iterate over it and get it to pass the test, right? So CD4ML seems like bringing all of those practices, but then changing it to apply to machine learning, which has a different nature.
Yeah, there's an aspect of quality as well around like assessing if there's any bias that was introduced while you were training the model, right? So one thing I like to tell people is the quality of the model is only as good as the quality of the data that you're using to train it. So if the model is coming up with bad or crappy answers, it's probably like don't have enough data, or the data is not good enough for the training. And if you don't have the good data, or if the bias is already in the data, the model is going to be really good at picking that up and using that to make a decision, right? So there's a lot of tools also coming up in that space to try to help us understand what the model is picking up as important features or things that are in the data sets that are making the model lean towards a decision or another. And also like to try to maybe assess the model against different slices of the data. So if you're worried about like some type of bias, let's say like racial bias or gender bias or things like that, we can use some of the tools to say, like, okay, let me assess the model against this subset of the data slice. And how does it perform in that subset? Or is really good in this subset, but it performs really badly in the other one. So you need to have all these multiple lenses to assess the quality before you're happy to put it in front of customers and move to production. And as David said, like a lot of these decisions might not be the data scientists or the engineering team to make. It's really about like getting the business on board with understanding what is happening, understanding what's driving the changes, and also during this promotion of process to get to production.
I saw a paper in the past week that said, I'm not going to use all the right words here because this is not really my space, but essentially the paper said if you use a machine learning model to create a strategy, if there is an unethical but efficient strategy, the machine learning model will find it and exploit it. So, and the way I interpret that is that unless you put some guardrails around use of machine learning in any context, it is going to find unethical, possibly biased ways of exploiting patterns in the data.
Absolutely. And it's not doing that on purpose. It's more like it's trying to learn what are the things. It's trying to find patterns, right? Like, and like if something is in the data, it's easier to identify. You will pick that up quicker, and you will amplify it.
And yeah, you can quantify that in different ways in terms of the model's output, but you can also, as we had at a client recently, you can also have conversations about what data is fair to use in the model. So what data should the model be able to see to make a decision? So in this instance, we were asking, well, what extent of historical data should influence a decision in the present? And that's typically a lot of fairness and ethical questions come down to that. Should we, given that the data that models are trained on has a bias in terms of what was collected, in terms of what decisions were made by people prior to attempting to use a trained model to make those decisions. There's inherent bias all the way through that process. Should we need to make some active decisions about what to include and exclude in terms of the data that the model sees? But then we can also look at its decisions. And often, I think one of the other things that we find with a CD for ML mindset is that typically looking at machine learning, it's framed as how often do we get the right answer, and so we might quote accuracy as a measure of model performance. But when it comes to a business scenario, we often care more about what is the cost of the different types of mistakes we might make, and so there might be highly asymmetric costs for making different types of mistakes, and those. It can be hard for, say, a data science team working in isolation to accurately assign values to those costs. They actually come down to a business decision and need for actually a diverse team to look at that and consider from many different perspectives the asymmetric costs potentially of offering finance to someone in a difficult position, or of refusing finance to someone in a difficult position as well. What are the costs in each of those cases if you would like to use an ML model to make that decision? And so those are things that are hard to do in isolation with a set of data and an optimizer. Those are things that really need to understand the context of where the data has come from and the context into which the decision is going to be supplied.
Mm-hmm. That's really interesting because, and I wonder how many companies are actually having that end-to-end rich conversation you just referred to, right? Data scientists with folks that are sourcing the data, with folks that are using the data, with folks whose business is going to be impacted by, the models. Because what I see is that a lot of companies are just still struggling in bootstrapping the fundamental platforms and pieces of engineering that needs to be in place to just collect the data and gather the data and assure that the data itself has some quality, some level of quality, some level of integrity, some level of freshness that is acceptable, yet alone, have a conversation that is this data biased or not? And is this model now, supporting making the right decisions for within the context that's seen? So we're definitely elevating the conversation, but I think the reality is that a lot of companies are still stuck in just bootstrapping and mechanical work that needs to happen, the pipelines and the engineering part of it. We talk about CD for ML, but there are a lot of buzzwords in the industry. We seem to have loved DevOps, and then we invented a whole lot of other ops vocabulary in that, adjacent to that. DevSecOps and DevSecBizOps, and now we have DataOps and MLOps. And so I thought maybe we can kind of unpack what does DataOps or MLOps mean to you, and how does that map to CD4ML?
The way I interpret, as at least the industry trends, it's about bringing that thinking. If we go back to the DevOps idea, right? It's like we want to bring people that don't work together closer together so they appreciate each other better, and we can together build something more. So it's not software developers throwing code over the wall for operations people to run. Data ops, ML ops is kind of the same. In some cases, it's still like that, right? Like the data science team might be trying to build models somewhere, and they're like, it's not my job to deploy this to production. There's another, either like a machine learning engineering team, or this is some other engineering team that's going to be responsible for doing that. And same thing we see, as you said, in like big companies doing data platforms. They might have like full data engineering teams. Their whole job, if you ask them, is like, oh, I'm the ingestion team. I'm just responsible for moving data from A to B. And those teams are a little bit closer to the operational side usually. I feel like the data engineers, they tend to worry more about those operational characteristics of the pipelines they're building, because there's usually elements of scalability and things like that they are already aware of. So the operational thinking there is already there, but there's still silo in terms of how is that data going to be used, or how is it going to connect to the business value at the end. So there's still some of these silos, and I feel like this industry trends that are coming up is to try to address that, to show people that actually we cannot disconnect things completely. Like, yes, there are areas of specialty, but at the end of the day, everything needs to work together. And we'll have the whole thing. It will be like data, sec, dev, ML, ops. It should be like one big term with everything, because that's eventually what we want, right?
Is it called business?
Yeah.
Biz, tech, money, ops, ML,
Design
dev, data.
like,
And again, just like the DevOps mindset, I guess, with all those sources of change and that iterative approach, like the development of the model doesn't finish, or the development of an ML solution doesn't finish when in the first release. And often we're using techniques like active learning, for instance, to continue to label data to feed back into the next version of the model. And so the solution isn't how do we push a model into production. It's actually how do we design a user interface to deliver, or a user experience to deliver that to the customer. But also how do we potentially develop a labeling or an active learning interface for internal teams or for labelers to continue to label the data. And so
improve the model, right?
Yeah, it's actually a whole ecosystem of technology components that need to work in synchrony in an operational sense. And so it becomes a very, very big concern. And it should be. It's not a matter of building the operational infrastructure and then starting to deploy models on it. It's actually an iterative process that cuts across all those concerns over and over again.
Yeah, I think CD4ML, our approach, we've been doing this in software for a long time. So like for Thoughtworkers, it's kind of second nature, thinking about things in those senses. Yes, of course, we want to release and it will improve, but that's not how most of the industry thinks of it and some of how they operate. So I think CD4ML will be our approach to like how those Thoughtworks does ML ops or data ops. Like this is what we're trying to think is it is going to be a continuous improvement process, and maybe the first release is not going to be the best model, but we want to try to get some feedback. We want to see how the user experience of using that model is going to be, what kind of impact is actually going to have. And sometimes it's hard to get the data scientists out of the trying to keep perfecting the model as much as possible, right? There's a tension there in trying to come up with a better model. We can always get better, but I think we want to improve the process so we can keep getting better and better and better, right? So we don't want to find a final stopping point.
So I'm curious about something. We're talking about machine learning models, ability to sort of respond to changes in the environment, all that kind of thing. Do we have a sense of how well ML models responded to the COVID crisis? Because like we saw a lot of, empty shelves at supermarkets that were caused by sort of problems in the supply chain. And my understanding is that was more about the fact that supply chains are so well optimized that if anybody buys a few extra groceries every week, there's no slack in the supply chain, so you end up with empty shelves, right? So I don't think that was a failure of ML models. But I'm curious, like, do we have any stories of how those models responded to a gigantic change in sort of world situation?
Yeah, I think there was a good example from Amazon in the States where the ability to deliver within a certain time frame became the number one predictor of whether a customer would buy from a supplier, whereas previously it was based on a range of other factors. And I think, we sort of summed it up as we trained computers to behave like people, and then people started behaving differently. And the computers, in some cases, haven't been able to catch up. And so this is, again, where an iterative process can help. But if you don't have enough training data, if people's behavior continues to change, you get these sort of non-stationary, as they're called, changes in the data, then we're either have to find ways to train on smaller data sets or weakly labeled data sets, or to be able to dial up and down the ability of a model to influence a process, if that makes sense. So how much we hand over to automation and how much becomes augmentation. And so those are all capabilities that speak to having a continuous delivery ability.
Yeah, your example about toilet paper, like grocery or like retailers, I think a lot of that planning supply chain happens because they're trying to, it's based on demand forecast, right? So like they have this kind of models, they're trying to predict how much they're going to sell, and they buy based on that. And those models are usually, there's a lot of things that are not really sophisticated. It's like regression models. So they learn from past data, which is how much we saw in the past. And I think no one had the COVID training data sets to show like how is that going to change when something like that happens. So I think the models wouldn't be able to predict that. But it also highlights, I guess, the importance of having all the controls around it, right? So like how do you still keep the supply chain running? There's going to have a lot of people and all the systems around to support, like, how do we smooth out this demand? So, because now every store is going to want to order all the toilet paper all at once, and like we're not going to be able to fulfill that all at once. So they have to basically build some compensating systems around those models until the model can actually see a different data set and pick up the new patterns and start planning again. But I think that was a bit unpredictable.
So we talked about kind of CD4ML and maybe the last mile of that. I mean, there is no last mile because it's all a loop, but towards the kind of the training and the testing and all of that. But before that happens, the availability of data at scale, historical data at scale from, rich set of domains within the bounds of organization or external to the organization is a foundational piece of it, right? And for years and years, we've had various kind of technology or architectures to make the data accessible. We had data warehouses, and then we've had data lakes and data hubs, and recently we added data mesh to the list, and that's kind of one of the items on the tech radar this time, which brings attention to I guess it's the convergence of engineering practices and distributed architecture practices, and now data, right? It was interesting that, when InfoQ kind of called out data mesh as an architectural trend, it was something that had this year, that's something that had never happened because we haven't applied or thought about architectural patterns the same way that we apply them to operational systems like microservices or monoliths and so on. We've never done that to the data management systems, right? Data management systems were often operating at maybe a different level. So that's another area that maybe we could talk a little bit. Just this whole decentralization approach to decentralizing data identity kind of architecture so that data can be more readily available to the models.
Yeah, I think that we've talked a bit about moving fast and being able to adapt, and I think that the key thing that a central architecture can't do is enable teams to work autonomously and respond to changing conditions in their circumstances. We need teams to be able to own their solutions end to end, and if they now include ML models, that means, as we've discussed, owning all the sources of changes that feed into those ML models. Not necessarily building all the technology bits, but having self-service access to all of those technology bits that enable them to do that. And then, as you were saying, when you have a multi-domain, a large, rich organization with many domains of data and rich data sets, a lot of the value often comes by combining those rich data sets from different parts of the organization to provide more predictive signals than would be possible within a single domain. And so how do those teams collaborate in a peer-to-peer way is the big question we're trying to answer without having to go through a central team that determines what data is available, what schema it's made available, what level of quality it will be made available at, how far down the roadmap that data will actually be usable into the future. But rather, we need teams to be able to collaborate in a peer-to-peer way, mediated by a technology platform that enforces the governance framework that's been determined, but teams to collaborate peer-to-peer to be able to execute on their plans and achieve their objectives in an autonomous but coordinated way.
Because arguably that sort of is the reason that people haven't been talking about data architectures so much, because the strategy was put all your data in one place. Whether that was an enterprise data warehouse or a data lake, like data lake just was changing the underlying tech for shoving all your data in one place. And the approach to making it valuable was, well, it's all there. So that's where you do your correlation and your creation of value by joining disparate data sets. So I don't know. I really want to call out that with more of a peer-to-peer model, that is absolutely challenging decades of thinking because the lake didn't really change very much. Is that fair?
Yeah. It enabled us to collect more data.
Yeah, I mean, the data lake enabled us to put, okay, it's all in the lake and we're starting to store it in a more raw format. So we get some benefits from doing that. But fundamentally, we haven't changed the strategy of putting it all in one place and then hoping that good things happen.
I completely agree. And I think maybe there's there's been evolutionary changes there, like how the data gets in and gets out and whether there are streams involved and more real time involved. But fundamentally, it's been moving data from one place to another place and then putting it in one place to give access to other folks. And I think because of the sheer volume of the data and kind of the technical bare metal challenges that we've had in terms of just serving it and moving it and storing it, a lot of the architectural thinking has gone to that technical layer, right? The grid architectures or the distributed file architectures. Those are physical layer. I mean, from my naive, end user perspective, those are physical layer architectural concerns that needs to happen. But this logical layer architectural concern, which thinks about the actual user, like as David was mentioning, these autonomous teams, and then how do you lay out another logical decomposition around that physical layer to give this sense of autonomy? That's the part that we've missed so far. And it's been one logical component, which is the lake or the warehouse.
I like one of the things from the data mesh approach that's really good is bringing that data product thinking, right? It's like, think of data as a product and the team is owning the quality for the data, because that's another problem, right? Once we move somewhere else, it's not my data anymore. And then someone else moves somewhere else. And then 3 layers later, no one understands the data anymore and the quality is bad and we complain, and then we have to build projects to try to improve the quality. I think with data mesh approach is more like thinking of data as a product. You have product team that will be responsible for that quality. They advertise to everyone like what the data is and what it isn't. These are the ways that you can access it. Is it through a stream? We'll publish some events here that you can consume, or if you need a historical data set, here's some other ways that you can consume. And making that accessible and easy to explore, it's really good. it is a merge of the architecture from like systems architecture thinking that's coming into the data space that I think, as you said, wasn't there before. Like a lot of data architecture was more about the structuring of the data or like the schema modeling, like more the data modeling. But I feel the architecture thinking, like how can we split responsibilities within the data domains as well? Like how do they align to like our core domains of the business? We've got transactional systems and data products that live together in those domains and exposing those data sets. It's a much more rich kind of ecosystem that you have to design or govern. And I think that's evolving and it's converging as well. That's one of the trends that we are seeing.
I have a question about something with data mesh, if it's okay to dwell on the topic for a bit longer. So with the data as product, right? Like you're creating a data set that others can consume. One of the traditional problems with data is that people start using it and then they expect it to be the same forever. And they get upset when you change it or mess with it or do anything different. Does data mesh speak to that in any way and have a strategy for helping people not get quite so stuck on the data that they're receiving?
I think what that conversation that we just had around data as a product, one of the kind of attributes of this data to be a product is providing some level of contract and supporting that contract moving forward is baked into the interface to that data. We often have a lot of conversation is what is a data product? One of these nodes on this mesh that is representative of the data. And it's not just the data itself, it's data, code, and then interfaces to get that data, code that is actually processing and generating and maintaining that data, interfaces to get access to them, and ultimately data is the content that we are sharing. And those interfaces can and should, apply, the lessons that we learned designing services and designing APIs, not necessarily to abstract the data on another layer, but support, forward compatibility through indirection, for example. So having schemas as part of those interfaces that defines what is the schema, what's the version, or the URL that gets you to that underlying file. So you may still provide, a file-based access or a SQL database table access to the end user, but you will provide that through an interface, will give you a level of indirection to say this URL will give you all the information about schema, what version of the data, and where you can get it. And if that version changes, then that URL will change. URL will take you to somewhere else. So you have ability to gracefully change the data and gracefully retire the old versions if you don't want to support. Which is essentially what we did in kind of microservices world or services world.
Said it better than I could. Obviously we can't deal with data that doesn't change, or we need to be able to work with data that changes. And so the argument that the data shouldn't change, we can't work with that. And so then if we accept that things change, as Zhamak said, we've got established patterns for the services provided by microservices changing. The services provided by a data product will also change over time, but we have established patterns for tracking that. And in data, I guess data mesh calls out CD, a number of different decompositions of continuous delivery. It's CD for the infrastructure, CD for the software, CD for the data, and CD for the ML models as well. And so for your CD for data, I consider that as being able to track all the changes that the data has been through and be able to reproduce that if required. And so this allows us to deal with changing data. And in much like we can have contract testing for services, we can have contract testing for data. It becomes slightly less deterministic. We might be looking at distributions, but at the same time, we can set expectations around expectations of a data set as a consumer or as a producer of that data set as a product. And that can feed into the definition of the data as a product.
Yeah, I'm really excited about this whole new category of tests that we would write to decide where you are on that spectrum of integrity or quality, right? It's not as binary as perhaps services and capabilities, as you mentioned. It's more of a distribution analysis and it's a spectrum. So there's things that yet need to be evolved, and I think they defined within data mesh architecture. I think we figured out the principles, we figured out some of the architectural patterns, but we still have to figure out some of the details. For example, we talk about similarly to SLOs or service level objectives, with usually very clear objectives of quality or measures of, guarantees of quality in terms of services, uptime and response time and delays and that sort of things. But when it comes to data, what does that mean to have a set of, I don't know, what's the name for SLOs or something that represents SLOs for data sets, so that we can give some confidence to the user and we can guarantee those.
Yeah, it's a somewhat unique challenge in that if the data characteristics change, the solution will keep working. It's just that it will produce more of those wrong answers, and unless we're that's right. Unless it crosses a discontinuity like that, and suddenly there's no toilet paper on the shelves, or suddenly a large number of pallets of toilet paper turn up unexpected.
I think in that space of decentralization or distributed architectures, we have another item on the radar called Decentralized Identity, which I was fascinated by it. There isn't a whole lot of applied, content yet. It's, I think, early days, but it might be an interesting one to cover and how it's applicable here.
The blip is interesting because it's talking about like identity specifically, right? Like how can we have a decentralized identity, either people or organizations, when you're in a decentralized architecture. There's no single kind of source of truth, right? For something that's something that a lot of traditional data management approaches, like we need to find single source of truth for things. But like in a distributed architecture, then maybe there's no single source of truth, but we still want to have a way to interoperate with each other and kind of like federate those ideas. So I think the blip is talking about some of the upcoming standards that are coming up in the industry to try to formalize how that works. But I think that also brings another challenge that we see with data mesh kind of approach, where we're trying to model these domains, not just identity, but like there's lots of business concepts that might have multiple representations within the organization, right? Like, so if you think a good example is a customer, like customer is probably going to be represented across the whole, whatever your business is. Yeah, you're going to have multiple views of that customer. And then again, there's this industry trying to like, we need to have a single view of customer. But in a federated kind of architecture, you want to support different things that you want to do with the customer, but you still want to be able to bring back together somehow and make sense of how the richness has evolved across. So again, like there is a push. It's a push and pull kind of system between like, do we model that in a central place and make that the single source? And then everyone is going to have to come here to get that customer information. And then we're going to broker and we're going to be the owners of that. Or are we going to allow this richness to exist across the architecture? But we'll come up with a way to be able to federate that concept that if someone else later wants to join them, they can actually say, oh yeah, like in the support domain, maybe the customer, this is the complaints that we got. And, but maybe from like, I don't know, the transactional side, these are the sales that we've got with that customer. These are the products that they like to buy and things like that. And you allow to have these multiple views of that core entity throughout the architecture, but at the same time being able to connect those dots and still be able to join them when you need them.
Yeah, I think this decentralized identity has two interesting kind of aspects to it. One is what you just described, Danilo, which is these identities are spread across different domains and maybe just some fields or different profiles or metadata associated with them in whatever field domain that they're in marketing system. You have some information about your customers, your order management, you have a different set of metadata about your customer. And ultimately, I'm sure David would love to join all of this data to actually create a feature set to train models to get toilet paper to them. We're going to abuse this toilet paper example. I'm so sorry, everyone. It's just stuck. But then the other I think interesting aspect of it is the entities themselves, like the customers or the patient or those core entities, they own and then they generate those identities that live across multiple domains and multiple organizations, and then they have in a distributed cryptographic way be able to authenticate that this is them and prove who they are, which opens a whole other set of possibilities of sharing data across organizations, right? Like your health data that you can share and move from one provider to another.
And even within organizations as well, when they're big enough, as Danilo said, we've had emergent distributed identity, decentralized identity in the first sense that you described, as a result of different domains establishing their own customer management systems. And then we have this push to somehow centralize or create a common identifier, the single view of customer. But shouldn't we put that into the customer's hands to say, do I want to be, as you said in the second interpretation of the decentralized identity, does the customer want to be identified as the same customer holding multiple products with different parts of the organization, for instance? Or do they want to separate? And, this also comes back to one of those questions of the cost of different types of mistakes for predictive models. If we're in a single view of customer scenario, there are different costs for accidentally overmatching and accidentally undermatching customers in that scenario. So, decentralized identity as a deliberate architectural construct that puts that power back in the hands of the customer, but in a way that makes it easy for organizations to provide services to the different identities that a customer chooses to adopt. That would be a real enabler for dealing with a lot of the complexity that we're seeing as a result of the emergent decentralized identity phenomenon.
I'm curious, on a related note, where we're at with the ability to sort of share data, but then rescind that later. So there's this sort of notion that I want to be able to share some data with you, but only until I decide I don't want to share it with you anymore. And, to my naive mind, once you've given someone some data, well, they've kind of got it, right? Are we approaching mechanisms to be able to sort of take that back and wrest control back again?
I think so. Like that, some of the regulations, right, that we see, like some GDPR and I forgot the one in California, CCPA. Yeah, like there's some regulations that are trying to give the power back to us as consumers, right? Like the rights to be forgotten, or I want to be able to know, like, what is all the data you have about me, and if I choose to, I want to ask that you forget about it. So there is, at least from the regulation side, some progress I think being made. But yeah, I agree with you. Like it's as a technologist, we're always skeptical. Like unless we have some guarantee that the data has actually got removed or some evidence, then you can never be sure that they actually deleted all the information they had. And a lot of the systems are not even built to be able to do that, right? Like it might be like a big effort just to try to be able to provide you that feature.
It's not like an episode of Mission Impossible where this tape will self-destruct in 10 seconds. You can't really do that with data. So it's more of a policy and regulation thing than a technical one at this stage.
Yeah. And I think companies are starting to, especially with this regulation, they're trying to build that discipline and like build the tools to be able to do that. But how well the implementation goes, and as I said, probably it's going to require effort to enable systems to be able to have that as a thing.
Yeah, I mean, until data sovereignty becomes a real thing, that you own your identity, your data, you generate the keys that represent you, and you destroy them. You can track them, destroy them. I think that's just as a regulation and some band-aid to be able to just enforce those regulations when somebody pulls, the trigger to do that. It's not a by default state of the system, and I think. When we get to that point, we have a very different model of economy where, things would look very different if we own our data and if we can pull that data back, or we can share that data by choice. then we wouldn't have a free internet where we pay with our ads and purchase of ads. So I think that's that's a different episode to talk about.
But yeah, I think it is. Yeah, it's being driven by regulations at the moment. But as Danilo said, I think we're seeing more provision in the technology to be able to surgically delete primary data products and all their derived data products within an organization as well.
I don't want to derail the conversation too much, but like one pet peeve of mine, like now a lot of the implementation is like now every website you go, right, like they're gonna ask you for cookies and you give consent, and there's like 5 pop-ups before you can get to do anything. From a user experience perspective, that's horrible. And like we're basically training people to ignore that and just accept that, which goes back to what it was before. So we put a lot of effort and like we didn't think about the customer experience and giving consent about how the data is going to be used. We implemented such a bad way that we train people to ignore it. That's a really bad kind of outcome, even though the original intent might have been good.
I mean, if I was a company that spent millions of euros implementing GDPR only to have every single person just click through it and not read it, and actually it be a piece of legislation that goes nowhere, I'm supportive of things like GDPR, by the way, but you can see how organizations would be upset at the expense that they had gone to for the apparent little gain.
Perfect. So we just to kind of recap, we talked about kind of the whole value stream of data gathering and collection and sharing, and then autonomous teams both using the data as well as putting the data into action through machine learning, and then continuous and iterative way of getting those machine learning models into production and observe them and use them. So when we think about this full value stream, to me, it feels like one continuum of processes and interoperable processes and systems. When we look at the industry and look at the tools, it feels like we either have a very data-centric of the world, it's all about pipelines and the data, or we have a very machine learning and AI-centric of the world, centric view of the world, which is around, well, data, we get it, and then we put it on a feature store, and then we use it from there, and we generate APIs or another set of data. There are some shifts that feels like we move this lens across this spectrum. So, for example, we have a blip on the radar, BigQuery for ML, that says, well, on this spectrum, let's bring now the machine learning to the data. So we just run machine learning within the context of SQL where the data exists. So I wonder how you see that. What's your point of view on that spectrum? And the shifts you see in the industry and the tooling that you see in the industry to talk about. And if you have any perspective on the BigQuery for ML, which is an example of that on our radar.
I think the specific on BigQuery for ML, it's a way to, like, I see a lot of tools making machine learning more accessible. And that's a good example of something, right? Like, so for people that maybe like you're a data analyst and you're trying to learn more about data science and create more models, and you're very used to working in SQL, BigQuery is a good tool to handle large data sets. So they're trying to make it more accessible, trying to bring the machine learning tool sets to an environment that's more familiar to you. There are a lot of tools, I don't know if you have it in the radar, but like, people talk about AutoML, right? Like trying to build platforms and systems that maybe like you do some level of the training or the feature engineering for you, and then you assess the model. So try to make it more palatable for people to start experimenting and building models. So I think, there is definitely, those tools help us bridge that gap, I guess, between the two and make things more accessible.
Yeah, and we've seen a range of different tools being used in different scenarios as well. Data Robot is another tool that we've seen deployed it has some components of AutoML in that you present training data and it has some components of CD for ML in that it will then allow you to deploy a model and track the performance of that model in production and potentially retrain if required. But we're seeing there's still, in terms of the discipline of continuing to evolve solutions in a customized way, you still need to be able to do that engineering across the whole stack. So the features that feed into Data Robot may need some significant re-engineering if you were to make a slight change in the way the model does its predictions or how that's presented to customers, for instance. But it does, at the same time, it exposes a lot of capabilities to a wider group of users within the organization. And so I think that the challenge becomes the balance between how repeatable is this use case? What are the risks of getting it wrong? Where are we on to go back to an old software metaphor? The utility strategy dichotomy. Is this a utility capability to be able to do some forecasting or do some natural language processing in a way that makes analysts in an organization more productive? Is that a utility thing like email or docs? Or is it a strategic thing that's a business differentiator? In which case you're not necessarily going to get an off-the-shelf solution, but you actually need to be able to line up all of your organizational capabilities behind a bespoke technology development effort.
It looks like we are back where we started. CD for ML or CD for data. So if it's all one continuum, or if there are tools that try to abstract complexity and make some of the steps of this process more accessible, as long as they don't violate the principles of continuous delivery, it's something we would embrace.
Absolutely, yeah. We frequently use off-the-shelf machine learning as a service or pre-trained models in that first iteration of an ML solution. And so that can be a really easy way to get started, but it doesn't provide that strategic differentiation. So it depends on where you're going to sit on that spectrum. You can validate that it's technically achievable, and you can start to get some sense of the value of deploying a model without a lot of sophisticated engineering behind it, and then iteratively improve the performance of that model and the differentiation if required.
To your point about convergence, I think absolutely right. Like even after the model is in production, we want to have the monitoring observability in place to see like how is it actually performing against real data, and that creates more data that you have to manage as well, right? So it's really hard to disassociate those two things like data and ML or AI. Like they are very intertwined, and at least from a strategy point of view for any company, I would say like you need to think about them together and how they connect. There are areas of specialty, of course, and like people might be interested more in one area versus the other, but not create them in silos and totally separate because they are intertwined.
I absolutely echo what you just there. I see these platform wars within the company. Oh, this is the data platform. No, this is the ML platform. And you're right. While there are specialties and specialized capabilities, there's an underlying common platform capabilities that needs to cater that continuum of iterative data to ML to data again flow. Perfect. So we could talk to you for hours and hours, but it's very late for you. And David's just about to start his day. So we're going to wrap up maybe our discussion with some, some thoughts or reflections individually from you. What do you expect to see within the industry? What sort of change you predict to see, or anything you'd like to leave the audience with?
I think we, and I'd like to see more of this ML move out of just the technical solution and into more of a product design mindset. And so considering what product features would benefit from leveraging ML, or what whole product classes would benefit from leveraging ML, and then how to approach building those digital products in a safe way, safe innovation. So being able to anticipate the failure modes and the biases that may be introduced in a solution, but also be able to make small incremental changes with all the technology foundations that support that, to be able to bring more effectively bring these products to market in the way that we've kind of we've developed that maturity in the basic digital product development space to be able to bring that to the digital products augmented by data and machine learning as well.
Yeah, for me, I think what I'd like to see it's maturing in the tools to support this all the things that we talked about today, right? Like all the way from how we manage data and how do we train the models and how do we assess the quality and get those into production. Like I feel like can be an explosion of tools now where like everyone is trying to solve the problem again. So the problem is there's lots of contenders. I think there's not like a clear standard or winner that emerged yet. So what I would want us to move as an industry is like, yeah, exploring all this is very good because that's what gives us more experience and perspective, but like have the standard body of knowledge kind of emerge and maybe the tool mature to a way that like we can actually implement this more easily without having to go back to the principle and try to apply the theory in a new environment. Ideally, the tooling would be more mature in a way that we can just start getting things going without having to build everything from scratch.
Yeah, and I think one key attributes of that tooling or thinking about those tools is ecosystem thinking, right? There's not going to be one system to solve it all, and how we can have standardization or technology that allows that ecosystem play between different tools. Well, thank you so much both for joining us. Thanks, Mike, for asking all the good questions.
Thank you.
Thank you for inviting us. Yeah, it was a good discussion.
Thank you very much for having us.